So one thing, the take-home message that I started with, and it is very, very evident from the discussion, from the presentation, and from all the presence of 200 plus people over here today, is that, first of all, the PFAS decontamination, remediation, and management technologies, this is the area which is much, much wider and in terms of scale and in terms of the scope, because it is so multidisciplinary, interdisciplinary, and transdisciplinary. And building upon, Nick's comment, that basically when you talk about, because I have my share in medical diagnostic radiology, so we say prevention is better than cure. So the question not only has to be based on or focused on detection, decontamination, remediation, and management technology, but the parallel discussion should also be how to reduce that to begin with. What is causing that PFAS in water and industry and everything? So today, some of the presentation from the academic perspective, you saw some of those slides which says, well, this is how it is being circulated from here to here, from here to here, but it is everywhere, right? So the question comes in there to all those people who are involved either from academic research or from industry or from government regulation development and policy development, or the community who are users of those products, that how to create alternatives for the PFAS. So we need to make sure that this particular ecosystem, with the partnership that we started talking about, academic research is basically the innovation engine, creating the ideas with faculty and students in a kind of free form and a cost-effective way. But they don't have the training or the resources to bring it to the market. So you need, partners. You need partners from industry. You need partners from community, investors. And you need an awareness of the infrastructure development that will drive the whole society into both of the sides of the prevention and the cure by creating the policies, infrastructure support, and creating or supporting this big ecosystem, right? So talking about this particular ecosystem, this is what we started about like 5 years ago when I got into the Office of Research. We started looking into the Technology, Innovation, Translation, and Acceleration Program. I call it TITA. Today, 11 of those NJIT projects that you are going to be seeing, and some of the people that you heard and you will be interacting with, we have 6 projects that we provided through CTR, seed grants, which is up to $150,000 each, to create the early translation validation. That means this is something at the TRL level 2 to 4. And then we hope that these particular partnership ecosystem will create additional partnership opportunities and engagement that will bring 4 to 7. If we get to that particular level, then I think the next step would be more obvious because we have broken the ice right over there. So for that particular purpose, we developed this Center for Translational Research with the funding from NSF. You heard this directorate that was recently established. It's called Technology, Innovation, and Partnerships, TIP. TIP has 2 programs, NSF Engine and Accelerating Research Translation. When that program came out, I fell off the chair because it was the blueprint that I started with TITA. So naturally, we participated in that, and we received $7 million now grant to formally create these particular program and these CTR workshops. So this is the 7th workshop. But then the deputy director of TIP got so impressed with us that they asked us to become the coordinating center for the entire accelerating research translational programs, which involved 18 leading universities in the nation and 17 mentor institutions. You heard from Craig Arnold today. He is the mentor institution, to us and also to University of Delaware. So 35 universities, we wanted to create this ecosystem with industry partner. And you know that every translational research project cannot be done without external partners, from community or from investors or from utility companies or government agencies. So now what we are doing is, we have created a national NSF art network portal. You are a privileged audience because on May 6th, I am releasing this to the national audience. Right now, it is only released to the 35 universities that we are populating the information on it. That particular art portal is targeted to create 4 national databases of the ecosystem. First, inventors, researchers. That includes researchers and innovators from faculty from academia, and also the students, right? The second, the industry partners who are willing to build the relationship, collaborative synergy, and the industry-university partnership in assessment of the innovative good idea and help the academic research community for early to mid-level translation, validation of it. The third, we are putting together the government agencies and the programs databases. So now that when you look into SBIR, STTR, or the other convergence acceleration or other particular programs, you will see this translational word almost everywhere, because that's how they want the impact of their taxpayer dollars, spent in order to create societal impact, but also the economic impact, right? And the fourth, but not the least, is the community and investors database, those who are the users, those who are going to define the specification, and those who are going to create the investment in a way so the TRL level 7 goes to 9 or become the largest scale translation and acceptance in the society. So what I would like you and request you to consider, each one of you table, there is this QR code. The URL of National Art Portal Network is very easy, artportal.us, artportal.us. You will remember that. But if you click on any of those QR code, the one is going to give you the membership page, which will tell you what are the benefits that you are going to receive for the membership. And the second is the registration form. So these are the 4 major benefits if you become as an individual member or as an organizational member. You will connect with the national innovation community as a part of the ecosystem, and you will have the privileged information and access to the translational technologies in action. So think about that. I'm creating a PFAS cluster at the national level now. We have about 11 those projects from NJIT alone. Just think about 35 universities. Once, by the time of the summer, I already have a few hundred members, but by the time we reach to the summer, we are going to have thousands of members. Just think about, you will, as a member, you will have access to the abstract of those transnational seed grants projects. You will have access to the information of the PI and also their industry partners. You will have access to the students who are involved on those particular projects. This is very important, as Nick mentioned. This is our obligation and responsibility to create future leaders. And the future leaders who have a sense to understand the market need, who have the vision to create a strategic initiative in technology development and translation. We want those skill set to be given an opportunity for our students to acquire so that they can become assets to the industry and take the leadership in the community and the society. You will get that from here. So I would, again, my humble request is, anytime you take that particular paper with you and just at your convenience, fill out the registration form, and we will create follow-up activities. Now, going back to the open forum. So one of the things that I just wanted to let you know, because I was just told, we have the live video streaming, and a lot of people are looking at the webinar or live streaming. But I got very, very excited to see this particular comment who somebody posted on the webinar with a question. So I'm going to put it out over there. Guess this, from where it is. It is from India. Somebody at the Indian Institute of Madras, which is one of the premier institutes. I graduated from IIT Roorkee, another campus. But IIT Madras, his name is Lakshmi Narayan. I hope that he is still on. He said, I have a question to Professor Wen Zhang. Professor Wen Zhang, are you still here? Come on the stage. So we have a question for you, surprise question. So to start our open forum. It says that given that both electrochemically active membranes and microwave catalytic membrane filtration target PFAS degradation, how do we reconcile the trade-off between energy intensity and material stability, especially under real-world high salinity industrial brine wastewater condition?
So this is a very relevant question.
Okay. Yeah.
That's a true question we're facing right now, especially when we devise a frontier technology. We claim that they are really, really frontier. So yeah, the question is related to the trade-off between the energy consumptions and stability of the materials we're putting into the traditional or commercially available membranes. We do consider those factors, but that's what we do, right? As a research side, we do all kinds of challenging tasks to enable future technologies. We're not just satisfied with the existing ones. We're certainly working with the current industries to test the baseline level of PFAS removal. But certainly we care about the new technologies we need to foster through the center and enable future partnerships. So my quick question would be, we're still working on it. I think there are a lot of literature talking about the energy consumptions when we run electrochemical systems. I do have a pilot scale system in the lab, and I can tell you that the differences between the laboratory operation and the field operations are very different. When we run electricity across let's say just a piece of paper size membranes over a huge pilot scale, multi-place electrode, we're talking about like a few micron amps over 5,000 amps. Think about it. Voltage is ranging from 110 to 250 volts, where we need electrical engineers to get permits to run it. So think about it. This is the big deal for everybody. As a researcher, we don't have such practical experiences and insight until we work with the industry people, right? So this is the benefits of joining the center, so we can work together. Thank you.
Very good.
Questions.
Thank you so much. So I would like to acknowledge Lakshmi Narayan from IIT Madras to listening to us. So please give him a round of applause. So now let's open the forum, and I would like to say a few remarks what I learned, and please add your comments and remarks to that one. Besides the wish list, which is, prevention is better than cure, and we need to look into what are the PFAS alternative besides that particular point. I gathered the summary of today's discussion and presentations can be categorized into three buckets. The first one is the detection, right? Detection and monitoring. So that actually sets the tone, what we're gonna do with those, and then how we're gonna create the regulatory compliances to make the product, whether that's a consumer product or the water, safe, right? So we also heard, all kind of numbers, somewhere it was said there are more than 6,000 chemicals, PFAS. Somebody said more than 10,000. And I heard in one of the presentations, somebody said more than 14,000. So take a pick. Now, this becomes a very difficult thing to handle to the first place, because if you are not targeting a problem definition with the specifications, it's very difficult to go into that particular broad range, right? So going back to medical analogy, because that's what I come from, if I'm looking into the atrial fibrillation sensor, I know exactly what I'm looking into. I can develop the sensor, I can develop the monitoring, and I can develop the treatment protocol over here. But when we have 6,000 to 14,000 chemicals, and that goes back to Wumi's question, which I promised that I will bring it over here. The question from the audience for all stakeholders and experienced leader is this: what are your thoughts? Where are you going to focus your technology development and translation and remediation technologies out of these 14,000 PFAS chemicals? What is the strategy here? Any comments? You are the leaders. Where do we start? Yeah. Could somebody bring mic? It's Arjun.
Hello. Yeah, it's daunting to know that we're faced with so many different chemicals. I think the key is to identify what's the problematic group of PFAS out of these 15,000, right? Like in analytical chemistry, or like who does a lot of monitoring work, they always look for surrogates, like a chemical that represents a larger group of like other contaminants. So I think the focus need to be like identifying those surrogate PFAS that represents different classes of PFAS and develop technologies to address those, and then demonstrate in a real world scenario where it should hopefully destroy the other PFAS as well. So that would be my 2 cents.
So any comment from the industry or looking into the clean water, the utilities, the last panel over there, what chemicals you are looking and how do you prioritize that? Or is there a need to prioritize? Yeah. Lauren.
Brent, I saw your hand went up too. So it's a good point, and again, I identify as an analytical chemist prior to this. So part of the challenge with PFAS and that group of replacement chemicals, I think right now what we've honed in on in the utility space is understanding that of the chemicals where we have better understanding of the public health impacts, that's really number one. We need to understand what the different types and classes and what the public health risk is from these chemicals. Some we have more information than others, and so I think that's really the first thing. Public health and the science really needs to drive ultimately what we target. Right now, what we know is that the carboxylic acid types, the PFOA, and other chains, that those are, frankly, the ones that we track more closely, because the sulfonated compounds are usually best retained by all of these technologies that we're using currently. Then you have other forms like the fluoroethers, the Gen X type, HFPO-DA, and those have different structures. So now we're looking at ethers and how do they react or absorb or are destroyed. So there's, as we're learning more about the occurrence, number one, improving methods to detect them, but also, working with what we have and being able to see what drivers we can pinpoint in terms of those that we have a good amount of public health data for, PFOA, PFOS, that are now regulated, and then go from there. That's where, on the utility side, we're starting from.
Okay, Michael.
So I think you made the point about multidisciplinary, cross-disciplinary, transdisciplinary. There's an audience that's missing from this meeting, and that's the biologists and the people working with kind of human systems. And I think that we need to better understand the pharmacokinetics of what is actually happening. There's evidence about cancer causing. There's evidence about mutagenic effects, liver effects. But we don't really know what the method, what the path of action is. If we understand better the path of action, I think that really allows us to answer the question that Arjun's trying to ask about: is how do then we classify them in terms of. So I think we need to bring in another audience to this conversation.
Yeah, sure. Give it next, Brent.
You may not like this answer, but at the end of the day, if I'm an end user, I am only going to target those things for which I'm regulated, number one. And two, maybe if I'm called to monitor for something that's not regulated because of the optics associated with keeping it in the water supply. And again, I'm speaking through mostly a municipal lens, but it probably applies to other end users as well. There are many utilities who have detectable PFAS, either not one of those 6 contaminants that are regulated, or or levels of those contaminants that are below the MCLs that are not going to pay tens or hundreds of millions of dollars for treatment. So until there's a mandate, either it's regulated or it's not regulated, but you have to monitor for it and you have to disclose it to the public, the reality is people are probably not going to do anything about it.
Actually, I love your answer because that makes perfect sense, because you can't go after 10,000, 5,000, or 6,000. You can't go after that. You have to define, like atrial fibrillation, you have to define one particular symptoms that you are going to deal with, whether it's destruction or decontamination or remediation or managing that. So that is actually a brilliant answer, and that's why I wanted to bring it to focus over here. And in order to prioritize that, we cannot make any particular prioritization by one group of the people. If you go to the academia and they're working in soil, I'm not picking on Dr. Sarkar, but he's going to say soil is it, right? Somebody is going to say whatever they are doing is the best. But that's why we need this ecosystem. That's why we need this, from innovators to the end user. And also the policy regulators, that what we need to focus on it, because if you create any scope of the work which is so wide and so unscalable, then I don't think that we can create an ROI of our investment with respect to our time, energy, and treasure, right? Okay, so that brings me to this particular part, perfectly timed. Right? So we need to create this innovation translation and impact through partnership and investment opportunities. And we have been talking this since this morning, so there is a consensus over there. So there is a corporate engagement and partnership, and this is a win-win situation because our faculty and students love to sit in their labs because that's what they do best, right? We need to bring them out. into the world. And industry people have their own challenges, and even though there are bridges being formed today in terms of the internship programs and all this, but there's a lot more in space to do. We need to bring them out, work with them. And then we need to create the policy and the regulatory. And that reminds me what Lauren pointed out and also Katie pointed out in their thing, that we need to share the data. We need to, whoever has discovery, whoever has the information, we need to share. There's one question over there. Yeah.
Yeah, I'm sorry. I'm going to provide a good news, bad news sort of situation, which is that on the policymaking and public advocacy side of things, if you want regulatory certainty, I would start planning for class-based, hazard-based definitions of plastics, microplastics, and of PFAS. You're going to see more and more states passing laws that are banning PFAS at a class-based level and that are starting to ban or require treatment of microplastics around the same. It's going to be some sort of class-based definition. It is not the water and the wastewater industry are indeed, Carol hit the nail on the head saying that you guys are the victims of this, you did not create this, but you're going to start seeing regulations around treatment and testing that are class-based. So when you're thinking about these PFAS, don't prioritize 1 or 2 or 3. You're going to start having complete phase-out requirements and complete treatment requirements, even if it's not yet technically feasible. We're seeing that around the corporate and the industry side. We're seeing a currently unavoidable use as the definition for industries being permitted to continue putting PFAS in things, which I think is a really important definition for everyone to be aware of. You guys are not the manufacturers of products with PFAS on them, but dental floss does not need PFAS on it. It actually makes the dental floss less effective to put PFAS on dental floss, but all those Easy Glide flosses have PFAS on them right now. And so one of those big steps for getting this out of our wastewater and our water treatment systems is stopping manufacturing PFAS and stopping putting it in things that are not currently unavoidable. And currently unavoidable definitions that states are starting to adopt are pretty strict. They're really fun, and if anyone wants to talk about that designation, please hit me up later. But I think that's when you're really trying to plan for regulatory certainty, that's where things are going to start ending up, because there is so much emerging public health data around the combined synergistic harms of microplastics and PFAS together. And this science is going to continue just absolutely momentum steamrolling us in terms of how harmful these two classes of contaminants are. Thanks. Sorry.
Thank you so much. That is a great comment, and that underscores that we need engagement and partnership across the entire roadmap of lab to market or innovation to market, right? And that's why this is what I'm proposing. Actually, Nick and I talked about it, and Nick alluded that into his opening remarks. And now I'm substantiating on that. We would like to develop 3 strategic collaborative PFAS focus groups. And as I talked about that the 3 different categories that we have, the first one is just having a dialogue established in order to understand what are the regulations what are the contaminants, and that we are going to focus for early research translation validation. That is basically the TR level 1 to 4. And that's initiated through the academic research, but these focus groups, I'm requesting that all the focus groups, 3 of these focus groups, would be populated through the leaders from all the 4 stakeholders group: industry, university, government, and community and end user, right? So we wanted to see that what we can access to the technologies in translation and what our strategic priorities should be to initiate the translational research innovations associated with it. The second is a mid to advanced level of translation. That means that this is like technology ready for pre-commercialization and investment funding. That is a bigger stake, right? But we need to help academic researchers and innovators to understand how the market validation, scaling validation should be done. Because, you know, on the academic side, we don't have any training on this. So we need those effective partnerships. So how to accelerate and facilitate this particular pathway of taking an innovative idea from the lab-based validation from like TRL 2 or 3 and taking it all the way to 7 before, you know, it would be investment worthy at the larger scale. And then we talked again and again that this has to be correlated with the regulatory and the policy development. So as a follow-up to this particular workshop, we have all you, this is the reason we asked you to register for the conference. You are in the database. We are going to send you the emails, and we would put together some Google form for you to volunteer to be a part of the group. So what are the next steps? The first, we are going to form these strategic collaborative focus group, and we will start working through Zoom links, you know, during the summer. And in the fall, we will bring a workshop of all strategic focus groups together to share their information, to network and create a strategy. And then we will see that how we're gonna fund that strategy, right? And then we will have another meeting in fall, but the bigger meeting where we are going to provide some strategic focus solution and action plan to this size of, you know, the group meeting in March. And I learned my lesson today. I'm not gonna do it here in this room. We will do in WEC, the Wellness you know, Center, where we are going to convert the big, huge, if you haven't seen that, we have a beautiful, beautiful facility with a huge basketball you know, court. We're gonna turn that into the banquet hall, and then we will do it over there. So I promise you, you will not feel that crowded next time. But I count on your participation. I request that you become an active partner in that ecosystem. You know, join the ART National Network portal, and then we create this particular focus group. So that brings me to close this particular, but before we break for the showcase session, I have a special announcement. Can you put that slide over there? So we have been talking all day long, and it can't be emphasized enough about this strategic partnership among industry, university, government, and the community. There is one particular person who has championed this particular you know, partnership and the leadership at the global level for a long time. And we have the honor of knowing that particular person. And I would like my chair of the Center for Translational Research, Nick DiNicolo, join me over here to introduce that person, and then I will substantiate a little bit more on that introduction. Yeah. This works? Yeah.
Okay, well, before I make that announcement, I just want to thank everybody for being here today and for participating. And really a special shout out to our co-host, Carol Wolczyk. Quite frankly, without Carol, I think about a third of this group would not be here. So Carol, stand up and please take a heartfelt thank you by everybody, okay? Okay, so we had great people here all day. We had elected officials, we had government officials, all great presenters. And I would be remiss if I didn't at least bring forward another esteemed individual that's really at the fabric and heart of NJIT, and that's our chairman. There he is. If you would come up here, Robert Cohen. We'd like to, yeah, you're surprised, come on up, come up. He's the chair of the Board of Trustees at NJIT and the heart and soul of NJIT. So with that, I'm going to give this back to you for a special presentation to Robert.
So I have to start saying that I have the honor and the privilege and pleasure of knowing Robert Cohen, and in the last 5 years or so, the more I came to know about him, the more I felt so amazed that how one particular person can make such a big impact and difference in healthcare. So I would like to share a few slides with you, and you will know that why we are having this special announcement and a celebration of Robert Cohen accomplishment, most recent accomplishment. Congratulations. Robert Cohen has been elected to the most prestigious award in the nation as the member of the National Academy of Engineering. Thank you.
You're good.
Just bear with me for two, because those people who don't know Robert Cohen, he's the fellow of the National Academy of Inventors. He's the president of Digital Robotics and Enabling Technology at Stryker, and the chair of the NJIT Board of Trustees. Robert Cohen, and this is my favorite quote, is visionary inventor who developed groundbreaking technologies used over 5 million joint replacement surgery worldwide. We know that our life expectancy and our aging process is not something that we can stop it, right? So later or sooner, we're gonna have our knee replacement or other things. Well, we have the inventor with us who created those technologies at about 29 patents and worked with the Stryker in order to develop those methods, procedures, devices, and the total technology for very successful knee replacement. Today, the Stryker is a brand of the knee replacement technology, and we have the privilege of honoring this person today. So don't take my word on it. The Stryker talks. Robert built a global ecosystem for translation to clinical practice, transforming the field of orthopedic joint replacement surgery with significant impacts on patient quality of life and longevity. So it's my great honor to recognize you and join me in congratulating Robert Cohen.
Oh, I have to say words. Well, the very first thing, if someone can explain to me that question from India, that would be great, because I'm not sure I understood half of that. Nick's going to tell me later at the bar. I stand before you as a proud alum, actually, of NJIT, and I think that's probably even more important, 3-time alum of NJIT. And the school is very, and actually to be able to walk in here today and see all you here talking about translational research and the opportunity for all the goodness that the faculty at this university do towards not just groundbreaking research, but working with students and actually figuring a way to commercialize that for the good of society, but also for economic benefit of a region and whatnot. I mean, it's just when I walk in here, I feel very fortunate. So I have a great job. I work for a great company, but I'm also associated with a great university. And it's this combination of all of that that I thoroughly get to enjoy. I thank you, Atam, for the recognition. This guy, Atam, works so hard. He's up till like 1 o'clock every morning. He's a department of 100 people already in one, and a lot of this credit towards bringing this recognition, not just to NJIT, but bringing recognition to the region and being able to partner with other universities that are at times our competition is actually extraordinary. And to get government, industry, and academia together, that is a winning formula. This guy is doing it. Thank you, everybody.
Thank you. So that brings us to the showcase, which I'm very, very excited about it. So this is not just like when you're going out of the door. No, this is the main event today. Because what you heard the whole day was just a preview. You wanted to talk about this, you wanted to see the potential of further exploring with these inventors or with these companies that are being showcased today, and there are 25 tables, so you have a ecosystem of 25 plus organizations and industry who are leaders in this particular field. So you want to take this opportunity to build the relationship, to understand what is going on over there, and then explore the future collaborative and partnership opportunity, and then again, join the ecosystem. So thank you so very much for joining us today. This is not the last time you are going to hear from me. Believe me, I am going to follow, and you can hold me by my words. So thank you so much, and happy showcasing.